Assalamualaikum to ones. Today we want to presenting about the loss forecasting. Before we start about the loss forecastings, we have to know about the objective why we do the loss forecasting. So for the first objective is to learn of tentang in a loss forecasting process. For the second is to create or design KT system. Third, to determine best design for the policy. Fourth, to the inspections on product defect, how it happens, and the solution about those problems. 5. To understand the molten metal process using cookable furnace. Now we go to the introductions about loss forecasting. What is loss forecasting? Loss forecasting is an interpretive pattern casting technique similar to investment casting, except that the pattern is made of a form rather than wax. The low boiling response of polymer forms allow these methods to simplify investment casting by eliminating the need to melt the wax out of the mold. Why we using loss forecasting? One of the advantages of the loss forecasting is the simplicity. The majority of the casting process are lengthy and includes more than a half dozen steps. However, loss forecasting is a relatively easy and straightforward process. After injection, polystyrene pellet into the mold cavities, molten metal is applied. The polystyrene pellets can vaporize due to the heat from the molten metal, resulting in a casting that can be expelled from the mold cavity.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Najanasi. I'm from group 10, section 10D. My mentee number is AA201011. I would like to continue my talk with equipment or tool that we use in loss forecasting. Up next, I will introduce you a simple procedure and process step by step in particular workshop. There are so many equipments or tools that we use in loss forecasting, such as polystyrene block, knives, model sand shovel, bellows, glue, silica sand, mold, metal shovel, clamps, and aluminium smelting furnace. The mold is used as container to fill the sand and polystyrene to place metal liquid. Next is aluminium smelting furnace. The furnace is used to melt aluminium or any metals in initial stage of the metallurgical process. Lastly is bellows. Bellows used to blow a small amount of dust after placing the pattern in the mold. Next, I will introduce you about a simple procedure of the loss forecasting. First, make a pattern, then reassembly the pattern, and pattern casting and drying. Next, sand fill and compaction. Moreover, metal casting. Lastly, cooling and shake out and clean out and finishing. So let's go to check out the process. First and foremost, we discuss our own pattern that we wanted to decorate on the polystyrene. A moment before, we use our phone to check out the best pattern that we wanted to use. So lastly, we choose a lightning emoji as our pattern. Next, we draw the pattern on the polystyrene and we cut them. For getting system, we also use a polystyrene. Next, we assemble together with getting system and the pattern that we decorated before. So we assemble them with glue or PVA glue and keep drying. After the pattern is drying, so we put the pattern on the mold and fill it with a silica sand using a shovel. After you see a getting system, we will make sure that getting system doesn't have any dust on it by using the bellows. It is because the melt metal we flow the polystyrene. Last but not least, we put the molten metal on the mold and keep drying on 2 hours.
Now we go for the discussions. For the question 1, what is a getting system and in what way affect the final cast output? So for the answer is the channel tossed with a molten metal flows to the die cavity are referred to as a casting mechanisms. Its main goal to ensure that the liquid flows smoothly and freely from the ladle to the mold cavities. The main purpose of getting device is a cut molten metal from the ladle to the casting cavity, ensuring that it fills evenly and fully.
Okay, so I will discuss about question 2. How can grease sands replace a silica sand as a mold for loose form casting? So, that we know that green sand is not a type of sand in and of itself, but is a 75 to 85% smear of silica sands, chromite sands or zircon sands, sometimes with part of olivine, sterolite or graphite. Bentonite with it we know that 5 to 11%, water 2 to 4%, clagate inert with is 3 to 5% and atratite with is 0 to 1%. There are numerous clay part receipts, but each achieve a unique balance of printability, soft finish and the ability of how to melt metal to degas. Coal, also known as sea coal, is partly burned in the form of molten metal, resulting in the release of organic vapors. Green sand castings for non-ferrous metal do not contain coal additive because the CO produced does not prevent oxidation. Green sand is often used for aluminium. Olivine sand is a combination of the minerals phosphorite and firelite formed by grinding donate rocks.
Now we go to the question 3. Highlight 5 defects that you could find in your casting product. What type of visible surface defect exists on the lost form casting product? Describe the cause and how to prevent it. What we can find in our product, our defect in our product is a sand sticking surface, porosities, open hole, wicking effect, and cut and wash. What is a cut and wash? Cut and wash can be caused by molten metal flowing at a high velocity, causing too much metal to flow towards the gate. How to prevent it? We can design the gating system properly, improve mold and core strength, adding more binder to the facing and core. Next, we go to the sand sticking. The cause for the sand sticking is a coating is too thin or puff or foam pattern is partially uncoated. The molten metal temperature is too high and negative pressure is too big. The molten metal process of the casting a small gap enter the sand. For the preventive, we can prepare of a good coating, constant complete coating with a certain tightness, especially in a cavity surface and corner. Second, keep proper pouring temperatures, and that's using the fine sand. Now we go to surface protrusions. Surface protrusion is a mild surface casting defect. The access plug hole is too large. There are protrusions on the surface of the foam pattern. Process make the surface has a metal protrusions. How do we prevent it? We improve the coating drying process to prevent the foam pattern from porosities and accumulating coating in inner corner. To prevent coating surface crack and vacancies. Now we go to open holes. These blowholes appears on the surface of the cast and are easier to detect than a subsurface blowhole. The cause for the open holes is a poor wetting of a mold and core and insufficient drying of a mold and core. We prevent it. How we prevent it? First, excessive moisture content of molding sands. Second, increased rates of solidifications by reducing metal temperature during casting. Lastly is a vehicle defect. Casting surface is less carbon. We call it vehicle defect. Defect of cast irons in a lost form casting. Casting surface has a layer of a lustrous carbon depositions after cleaning. So cleaning shows orange peel. We call a vehicle defect. Pouring temperature when other conditions are fixed. Wrinkle defect will be increased as the temperature increase. The thermal decompositions of a foam pattern is complete in high temperature, but the conductive to reducing wrinkle defect. How we preventive is use the high temperature of pouring.
Okay, I would like to share about our group observation. Based on the process that our group did, we were able to learn to create shape from polystyrene foam in a variety of ways. The pattern can be cut with paper knife, but it's more easier if we use hot wire foam cutter. Then, if the volume is high enough, the pattern can be mass-produced using a method similar to injection molding. Next, the extant polystyrene bits are inserted into an aluminium mold that is heated at low pressure. After that, steam is added to the polystyrene. Cuisine is to stretch ever further in order to fill the die. To finish the pattern, we do pre-made power scenes, runners, and baking pans can be hot glue on. We regulate permeability to prevent sand erosion. Finally, it acts as a shield, preventing molten metal from penetrating or eroding the sand while pouring. The mold is able to be poured after the sand has been compact. Science. The casting method in LFC is considerably more important than in traditional casting methods. Automatic casting is widely used. However, although it seems easy to solve, yet there are many defects in our products because the risk of open holes that affects gas porosity. Net shrinkage cavities cause shrinkage defects. Lastly, more material flow caused by product cutting failures. Then, I will show the pictures of our group final result after doing this low form casting. So, in conclusion, we learned that the low form casting is a casting process in which polystyrene, pellets and molten metal are injected into a mold cavity. The molten metal allows the pellets to evaporate. As the hardened pellets are evaporated, they form a casting can be expelled from the mold cavity. Low form casting is simple to do, has high dimensional precision, and is resisting to flash. However, the castings are usually weaker and more expensive to manufacture than those produced by other methods. Thank you.